No? I think it was.
Can I see something?
Yeah.
I got the date wrong. The LibreOffice date is this Wednesday.
Oh,
This
okay.
one. Yeah, this one.
LibreOffice is
Two
this
days.
Wednesday.
Yeah, 2 days.
Oh, actually, I realized one more quick announcement. October, there's an event called Hacktoberfest, which is run by GitHub and DigitalOcean. It's basically like if you make a commit on, I think it's either 3 or 5 commits on projects on GitHub. They'll send you a T-shirt and some stickers. So if you haven't done free software, open source stuff before, you're interested in getting started, search for Hacktoberfest. They have like lots of suggestions of easy projects to start with, lots of like getting started issues. It's basically any commit you can make, so like in the documentation, if it's code cleanup, if it's whatever, you make a commit, and then you can. All right, I'm going to turn off the lights, and George's going to start.
I have to say that Paul raised the bar too high for my presentation. I enjoy reading his technical prose when he presents the meetings and stuff. And yeah, when you read that, you might say that blocking things can have double sense. Yeah, you block something or you put things in block. So actually, blockchain is the second meaning. So I have an academic background, so that's why I'm starting with where I am. It's my hobby to be interested in the latest advancement in software technology and process development. So I have general knowledge in blockchain, all kinds, Ethereum, EOS, Cardano, and others. Machine learning, artificial intelligence, IoT, web, cloud, microservices, software architecture and design, security, mobile enterprise, open source, and agile software development. In my work career, actually, I dealt with software process development issues, so that's my hobby that's still there. Yeah, I have a university computer science degree at the oldest university in Romania, founded in 1860. Then I worked 10 years at the biggest research institute in computer science in Romania, in software engineering, testing, databases, project management. In Canada, I have 6 years industrial communication, networks programming, also some Windows configuration programming tools. I worked here at the BlackBerry operating system group, working with C and ARM architecture processors. 6 years in embedded telephony, voice over IP communication network at the General Electric branch here in Waterloo, United Technologies. And also I worked for a short time at Peer Group and Netscaper doing communication drivers and internet filtering software. So when we talk about Bitcoin, actually when we're talking about blockchain, people are thinking first of Bitcoin, yeah, like the Bitcoin currency, especially if we are going back 1 year or so, when it reached like $20,000 value, then it got people attention. So what is a Bitcoin? It's a payment network that allows anonymous transfer of money between peers without any intermediaries. From computer science point of view, this technology got my attention because at the beginning when I look at it, it looked for me like a utopia where you learn computer science, do not repeat yourself. While all the blockchain technology from Bitcoin, they do repeat themselves, and quite a lot. So Bitcoin is implemented as a blockchain. high-level understanding is a shared public ledger, a log of transactions between peers that is trusted, and it is maintained by an open, decentralized, fault-tolerant network of computers. So I hope to learn something from you today. So if someone has like a common sense general question that if you are not familiar with Bitcoin and you read this, what question you might have? I put quotes for trusted and decentralized because things are relative, so you cannot be 100% trusted or 100% decentralized. Yeah, there is an expert in software security, Bruce Sneer, and his point of view regarding blockchain is that we should use trusted in quotes, and other people. Yeah, if you go deeper into technology, decentralized also should be quoted because it's not 100% decentralized, it's not 100% trusted. Yeah. I mean, Bruce Schneier says if the user initiates a transaction from a phone to transfer some funds, if that phone is compromised, yeah, then maybe the transaction is happen on the blockchain not the way he intended. So you can use Bitcoin and blockchain in different contexts and different contexts. Yeah. So you can for Bitcoin, for example, you can refer to the ledger, or you can refer to the network of computers, or you can refer to the coin like an incentive mechanism for the blockchain, Bitcoin blockchain. So in a nutshell, how we should look at a blockchain is a chain of blocks that contains transactions, and so each block contains hash of the previous block. So that's the way you chain the blocks, and because hashes are high sensitive to changes, that means any tampering with the block will invalidate the chain. Because, for example, the current block, by the nature of this technology, because it incorporates the hash of previous block, it has the current block has actually the digital fingerprint of the first block. That means any changes you make from the first block to the current one can be detected. Yeah, because you have hashes. Yeah. And so now I want to get the notion of why the blockchains are needed. I mean, what was the reason they were born? Yeah? Birth. The reason of their birth is the people try to use technology to store value. Yeah.
Yep. Your previous slide, does everybody in here know what a hash is? Yes? Okay, cool. I just wanted to make sure, because it would make no sense otherwise.
Yeah. That's a good question. Actually, it's a challenge to take. I'll go into the hash more like detailed explanation, but yeah, you're right. So when we talk about value using technology, I mean, a classical way to handle value, money, like example is to use in the process to use people. Yeah, you use banks, you use regulators, and so on. But with Bitcoin and other blockchains that manipulate value, you use technology. Yeah. So the problem is how we can use technology to be sure that the value is still there if it is managed by technology. I mean, people are sometimes I hear scenarios where people want to use like kind of value-based technology and use a database. And I I'm saying if there's a database, how long it takes to change a record if a malicious attack happens to change a record of the value of that asset. Yeah, it's like few CPU cycles. Yeah, so the Bitcoin and the blockchain generally treat assets very seriously. I mean, first of all, the history of the transaction, it is shared about many players, so that if someone is hacked, the other people still have that history. Yeah? And then you have a permanent story. That means it's very hard. It's like very expensive to change that history. So the transaction of assets need to be immutable. That means hard to change. If you have no central authority, that means your trust increases. And then the ledger is still storing this history of transaction in multiple ways. Like quick example, Bitcoin database, we see here on the left corner that the ledger is replicated all over the world, and it contains who owns what, yeah, the users and the amount that they own. Now I just want to make here a note that this is an abstract point of view that is true for some blockchain. For example, Ethereum stores transaction this way, user and amount. But actually Bitcoin has a different model. It is called the ETF. So I'll get into details, but here I just want to clarify that they don't get the wrong impression about the way Bitcoin stores values. Yeah? So actually the coin, Bitcoin coin, is actually a chain of ownership with a complicated algorithm, but the wallet application takes care of these details, but in the end the wallet application will show you the record like this, yeah, the account balance. But the way it happens in Bitcoin is it uses the model that the fiat currency is using. I mean, the amounts are specified in notes. Yeah, you have 5, 10, 20, 50, 100 notes. Yeah, and when you do transaction, you get change back and so on. So it's more complicated. But yeah, and there is this Cardano blockchain that supports both the models of storing amounts like in Bitcoin and Ethereum. Just so what caused Bitcoin? Well, yeah, it was the failure of the centralized payment processing systems that are being centralized are vulnerable to attacks. Sometimes you need to do intermediation between the players, trying to resolve what is the truth. And there were attempts to do like electronic payment system like DigiCash. I was reading in the literature that it was subject to double spend attack. Double spend means you purchase something and then through a hack you can go and use the same amount and purchase something else. Yeah, so and also in around 2008, before that, there was this crypto anarchic movement that they wanted to remove the lack of transparency and centralization in financial transactions, and also they had this idea of voluntary economic interactions. I mean, the idea was if you want to improve a road, yeah, people interested in that should be able easily to use the technology to put funds toward that project and then have it run towards the goal they put it to grow. Any question? So Bitcoin was born in almost 11 years ago, November 1st, 2008, after the financial crisis. Satoshi Nakamoto, he issued this well-known paper about Bitcoin operation, like electronic cash system. And in January 2009, he had the first implementation of Bitcoin. Actually, the first Bitcoin transaction happened. So, how actually Bitcoin operates? It's yeah. First glance, it's simple, but if you go into details, it's complicated. So, how the transaction is initiated from a local client that could be a wallet application of a user, or there are Bitcoin exchanges where they are holding Bitcoins for you. So they either the wallet app or the Bitcoin exchange, they can initiate the transaction. So they generate this public key pair, and from the public key you generate a Bitcoin address that used to identify the user. The private key digital sign the transaction for against tampering and ownership, to secure the ownership transfer. The user creates the transaction to transfer funds between peers, and you need to specify your address and the receiver Bitcoin address and the public key, so that only the receiver can get the funds, because they can use their private key to access the funds. So the transaction is sent over the Bitcoin network in unconfirmed state, and the user waits for transaction confirmation by the network. So Bitcoin ownership, this goes back to 2 slides back, or further to back, when I was saying about securing the value by blockchain of Bitcoin technology. So what are the main ingredients? Besides the asynchronous signatures, asynchronous cryptography, and that includes the keys and the digital signature, you have the network that we will talk later about proof of work. You need to assure the consistency of the ledger about the amount owned by each user, to avoid double spending, and to be sure that each node that maintains the network has the same copy of the data. So for that reason, the network operates by the principle that writing to ledger should be hard and slow. It should be very hard to write. Yeah, it's not like a database, you just write a record in a flash of second. In a blockchain, just to preserve the value administered by the network, you have to make hard to write to the ledger. So here I just go to the public cryptography just for a quick reference. Now the Bitcoin account, you can think of it like a public drawer with a random label that is derived from the public key. And this is from like the Bitcoin wiki. It's the algorithm to derive the Bitcoin address from the public key. use like a base 58 hashing algorithm that removes confusing characters in the alphabet. Yeah, you can confuse 0 and O or L with I. So 858 hashing algorithm make sure that there is a little confusion in the format of the Bitcoin account. So how the transaction are built? You specify amount, source and destination, and the wallet app uses the user private to digital silent transaction, and the verifier in this case is the network node. Verify the initiator of transaction. Here is an example. If you go to blockexplorer.com, you can see the blocks, the transaction in the blocks. So the transaction identified by the hash. And here we see a transaction on the left, this address 17A16Q, and so in the bottom left corner, transfer 1001 dot something Bitcoins to these other addresses with the specified amount. And you can explore on this website, you can go into details about the transaction, the blocks, yeah, except the size of the transaction. So digital signature, just go quickly. Jason had a presentation, yeah, about this a few sessions back, and we talked about it a lot. Here is an example how digital signature are working and how the verification algorithm works. And here is another visualization how the transactions are happening and their digital signature and how the verification works. Yeah, now I'm talking about the chain of ownership of coins, Bitcoin coins, UTXO model. So that's the way Satoshi defines the Bitcoin coin in the white paper, like a list of transactions, and you are hashing the public key and the previous transaction. Actually, for the first transaction, we see that owner 0 signature is a digital sign of the previous transaction, and owners 1, and the same goes to owners 2 and 3. And this is an example how the UTXO model works. So for each transaction, you have a number of inputs and a number of outputs. So the inputs they specify the previous. One input is the previous output. Then you might ask how the whole thing started. We'll see later on that right from the beginning, right now until a few years later, the coins are inserted in the blockchain by a process of minting, where the miners that maintain, each node of the network is responsible to, when they are successful, we see later on, they are rewarded with number of coins. So that's the way the coins are originally. This is also from the Satoshi paper that explains that new coins are created or minted into the system as a network reward incentive. We see later on how it happens. I mean, if you want to get like a high-level view, there are lots of videos of the internet, but they are abstracting some things and they don't tell the whole story. Yeah? I mean, to fully understand, you have to be very careful, go through all these details. Yeah? So now, how the network operates. Network nodes, they are actually kind of administrators of the Bitcoin database, the ledger. So all the unconfirmed transactions, we talked about how the wallet builds the transaction center on the network. So the closest nodes to that client, they receive this transaction and they will propagate it throughout the network. Now I have to make a reference that Bitcoin network is unique in the fact that it operates in the most adversarial mode. That means you can assume that a node in the network is malicious. It can fail. It, for example, cannot propagate messages. It can tamper with the messages and so on. Yeah? But the network oscillator one still operates in this most adversarial environment. So this is an example. The Chiji Institute, they did the research on blockchain, and I took some pictures from their presentation, how the mesh network operates. Each node just communicates with their nearest neighbors, and so a transaction doesn't matter where it happened, because I said the client will send the transaction to the nearest node, and that transaction will be propagated throughout the network all over the world. Yeah. Right now it is estimated that Bitcoin has 10,000 nodes. That means the network is quite big, and the connections are so many. Yeah. So the network is called a DLT network. As I said, we have 10,000 nodes. The network is permissionless. That means anybody can join or leave the network at will. And it's still, the technology still works. Clients communicate when we have no single, for that reason, there is no single point of failure. Yeah, because each node on this network maintains a copy of the ledger with all the transactions and assets, as explained, and each node builds this ledger by itself. So it's not like a node gets a copy from another node. They have to build the network by themselves, and the technology through a verification mechanism assures that each node will have the same copy. Every 10 minutes a new block is block of transactions created and replicated throughout the network. The environment I said of adversarial discourse Byzantine fault tolerance, that means you cannot trust any node. It comes from well-known Byzantine agreement problem with some Byzantine generals that want to attack the city, but the generals can be bribed so you cannot trust the generals, but they need to coordinate at the same time the attack towards the city. And yeah, there is a lot of research. Leslie Lockwood, I don't know if you know about him. He received a Turing Award, the equivalent of a Nobel Prize in Computer Science, for solving this problem that we still have a solution if you assume that just a portion of these generals are traitors. Yeah, if majority of the generals are honest, then we can't solve the problem even in the adversarial environment. I mean, the problem is says the messenger has to travel from one general to another because they have to agree. One general says, I attack in the morning, so he has to inform the other generals that they need to attack all in the morning, but the messenger goes to an adversarial environment, might be killed by the enemy, or the enemy might capture the message and tamper with it, send another die, or so on. So, yeah, it's kind of analogy with how Bitcoin network works. Yeah. So, a miner is a node of the Bitcoin network. Yeah. And they are responsible to verify the transactions. There are some criteria to verify transactions, and have to pack this transaction into a block, and then they all these 10,000 nodes that I said, they enter into competition to validate this block. Right now, Bitcoin has a 1 megabyte size limit. There are other proposals to increase the size and so on. It's interesting to know that because, as I'm explaining here, there are many transactions initiated in different parts of the nodes, of the network, I mean, and each node can build kind of its own block. Yeah. Because in this situation, there is an issue with the bandwidth, network bandwidth. Yeah. So let's say the node is here in Toronto, the one is in Singapore. Yeah. So by the time the transaction initiated from here gets to Singapore, the guy in Singapore already might build a block with the transaction local to his location. Yeah. So you might be in a situation and guarantee that these blocks built by each miner are different. But the way the network operates is, in the end, all the nodes will agree about what block to use. Yeah, what will be the next block that will link to the previous. Yeah. Here there are all the steps used to verify the transaction, and yeah, there is a reference to what I mentioned with the block reward and so on. And that's called coin-based transaction and so on. If you go into detail, so what is the structure of the block? This is C++ notation here. The first 6 fields of the block are used to build the hash of the block. This hash that I mentioned at the beginning, that it is used to chain the block together. Yeah. The block contains within the last field here list of transactions, but because you can have lots of transactions, like thousands of transactions. Yeah. So then if you do a hash of the block, it is quite computationally intensive. So that's why they decided to do the hash of only of the header, the first 6 fields here. But yeah, how you can digital fingerprint the transaction into the header. So there is this, we see here the third field, the Merkle root, is a Merkle tree collection. Yeah, it's actually a digital fingerprint of the whole transaction. I'll go into detail later on. So that means if you change a transaction, the Merkle tree will change, and that will trigger a change in the hash of the block. Yeah. So this is why, for speed, the reasons why they are hashing only the first 6 fields of the block. It's called also block header. Yeah, and for example, the wallet app receive a chain of the block headers and not the whole blockchain, because the blockchain right now is quite big. You can Google and see what the size of the Bitcoin blockchain is quite big. So only the full nodes, the miners that maintain the network, they have the full copy of the chain. And the other one, like clients, they have only the headers. And we'll see later on how they still can get information from blockchain having only the header. So this is the block header. It's actually from the Bitcoin wiki. And so now another image of how the block is. So we have these unconfirmed transactions that are floating around the network. Yeah, each node receive the transaction, take care of replicating through the network. It might not reach the latest node, but each node first, when it receives a transaction, it uses an algorithm to verify the transaction and to see if you know the input value is greater than the output. Yeah, and so the blocks are created. Each node creates block from these unconfirmed transactions, and when the node is finalized, we'll see later on how it is chained to the last block. So each node will decide about a unique block that they have to use to chain their own copy of the blockchain. So here I go. What technology? Well, we are using SHA-256 hashing algorithm. Merkle tree that I mentioned. You can go and get the details. Merkle tree is like a binary tree that the leaves node they have transaction hashes. Yeah, and then as you go on the hierarchy, these hashes are summed together till you go to the root. So the root will have like a kind of digital fingerprint of all the transactions in the block. And Merkle tree is used to prove that transaction is part of a block. And here from the Bitcoin wiki, they describe how Merkle tree and Merkle root is computed. Yeah, they use double hash of SHA-256. The reason is the double to increase the security. Yeah, because people were thinking that you can reverse SHA-256, so that's why they are using double. The SHA-256 hashing function, what is specific is any small change does a radical change in the output. Yeah, if you add just a dot at the input, the output is radically changed. Yeah? So now I'm talking here how you use a Merkle path to prove that the transaction belongs to blockchain. So I think that this picture is more indicative. Yeah, we have the list of transactions at the bottom, and then the leaves are the hashes of the transaction. And now, for example, a wallet might say, can you send a query to the miner saying, can you tell me if leaf E, if transaction E It is part of the blockchain. I mean, they want to know if once you submit the transaction, if the transaction has been accepted by the network and included in a block. Yeah. So the miner, yeah, because you have a light client, he wants to send as little information as possible. So what the miner will reply with Merkle root that goes on the left to H, A, B, C, D. Then it will send the ones that are circled in what is color. Then it will send H, G, S, G, H, and that's it. So how the wallet works? Sorry, and leaf F. Yeah. So how the wallet works? He queries about transaction E, so he can compute its hash and gets leaf E. Then he received leaf F in that short message from the miner, so he can add these two hashes and goes up to the tree, goes to H, E, F. Are you following? And so then he uses the other hash he received on the right, yeah, on the level 3. He's using H, G, H, adds this together and gets H, B, F, G, H hash. And then because it received H, A, B, C, E, it adds them together and gets Merkle root. So once he gets Merkle root, he goes in the header and compares, is this Merkle root equal with the one in the header? If it is, has a proof that the transaction is part of a block in the blockchain. Yeah, so I am describing here, yeah, the phone stores the wallet application, yeah, stores in the second step here the blockchain headers, and you receive the Merkle path, yeah, the one highlighted here, only the ones, and then computes the Merkle root and compares with the value in the header and have the proof. So this, like Merkle trees are used, for example, in GitHub. There are many technologies to do a fast computation of yeah, to see if things belong to something. And now, yeah, this is a summary how the block is built. The last point here is how you determine the right block. Yeah, that I will address in the next slide. This is another visualization for the better understanding. Yeah, how the blocks are building. We have the block transaction. These are the headers, and then how the blocks are chained together. A quick note here: what's the difference between blockchain and database? Yeah, as I mentioned before, because the blockchain makes hard to write. That's the main difference between database record, and because you have all these hashes and digital signatures, it protects about tampering. So now, how you select the right block? As I said, mentioned before, all these 10,000 nodes can build their own block. Yeah. So then, how you determine which block should be part of the blockchain? Which is the next block that you need to link to the previous? Yeah. So it used this mentioned at the beginning. You have to do lots of work to prove that you worked on that block. Yeah. So it is inspired by Hashcash algorithm. So Adam Knapp, he came up with this idea when he said, I'm using a message board. I want to avoid spam. Yeah. So how can you avoid that? You put the client who sends a message to spin the CPU for half a minute. Yeah. So then, if you want to send 10,000 emails, to send that message, you have to spend half a minute to multiply by 10,000. Yeah. So you avoid spamming. So Satoshi Nakamoto will use this idea. He said, let's put each miner, each node on the network to do lots of work to prove that they did some work on that block. Yeah. So then they said, how can we do that? So you establish like a pattern. You need to compute a value, and this value has a pattern. So the pattern is how many zeros. The number is quite big, and if you put a number of zero in like this number, let's say you say should start with 10 zeros, and then I don't care. Yeah. So that means that the target that each miner has is they need to do this computation and come up with a number that is smaller than the target. They call the difficulty of the blockchain. Yeah. And this number is adjusted every 2 weeks. And the idea that if the nodes use more CPU power, yeah, they can outrun other nodes. Yeah. So then you'll see that in the blockchain, how fast the nodes are, how fast the blocks are added to the blockchain. So they are adding very fast before 10 minutes interval. That means their CPU power is stronger. They make the difficulty harder. Yeah. So how? Yeah, this is like Gigi has an image of how Bitcoin operates. So on the left you have these transactions that are flowing, then a block is built, and there is this timer that you have 10 minutes at your disposal to determine which is the next block, and the winner of this competition, yeah, the node that builds the correct block, it is rewarded with Bitcoin. Let me see if I go a little bit further. How the node is using their hash power to hash the block header. Yeah? So each node build this block, then it starts competing with other nodes by hashing this header, and the hash should be slower than the target. But what varies in the block is this. I mentioned at the beginning the notion of nouns. So there is a field in the header that let me see if I find it here. Yeah, the last if you see which one, the second from the bottom. Yeah, this nouns field. It is incremented on each step during the hashing. Yeah. So the miner, the node on the network, hashes the block, checks with the difficulty. Mostly, for sure, it fails. Then it will increase the nouns and checks again. So that's why it's very CPU intensive. I mean, you have to increase these nouns like to a huge number to get a chance to get the hash lower than the difficulty. So in this way, this is called Nakamoto protocol. Yeah, it solved the problem of Byzantine agreement, because the first node that is successful is like a bingo game. Yeah, the first node that's successful to get a block with a hash smaller than difficulty wins. Yeah. So as I said, each node builds its own version of the block. it starts increasing the nonce and hashes the header and compares with difficulty. Yeah? And one of them will win. I mean, we are talking here like tera hashes per second. I mean, right now the network is crazy how much CPU power it is used. And I think they reach like, there is like 7 nanometer chips, specialized chips to do the hashing. And people are saying that actually the mining hardware is pushing the, you know, the silicon technology the hardest. Yeah. Because I mean, what's the motivation? Because the miner that wins, I mean, who finds a valid node, he is he's rewarded with bitcoins. Yeah? Right now it's 12.5 bitcoin, multiplied of $9,000. How much is a bitcoin right now? Yeah? You have incentive to you have to play this game. At the beginning it was easier, but by the time you know, technology progressed, it's more players joined the game. And yeah, it's harder. Yeah. Then, as I said, difficulty by design, it is so that doesn't matter how fast hardware we have. You should always get a 10 minutes interval, approximately, a block. Yeah. So if you are CPU power, people are using the GPUs or ASIC specialized chips for Bitcoin. You have to get ahead. But the algorithms will increase difficulty so that you cannot get a block earlier than 10 minutes. Yeah?
One question. So, let's say I'm a wallet and I'm sending a particular transaction to one or to several nodes. How does that, how do I register a transaction?
The wallet app knows the Bitcoin protocol. If you read the documentation here, the Bitcoin protocol can tell you if you're a client who are the nodes close to you. So the wallet app decides, you know, usually they send to the closest node because the time is in play here.
Yeah.
Because in 10 minutes you have to finish a block, so that you need your transaction to get into the block. Yeah.
So I get the transaction, avoiding that node, it makes a block with my transaction, but that block never gets to the blockchain. So the client sends that transaction elsewhere, right?
I don't know about the details here, but yeah, because the node can be malicious. Yeah.
It can be malicious, or
it might not. Yeah.
I'm not an expert here, so bear with me. Please don't throw anything. But one of the principles, in my understanding of it, one of the principles of how the Bitcoin blockchain works is you have these transactions, they get around, you have these verifiers who kind of say, this is a collection, I've signed it with the nonce, and you know, and released it, those are the miners. And so you have all of this going on, but the question is, how do you develop trust? And trust is developed via what might be called a quorum model. Essentially, half plus one needs to agree, and that agreement is what I call eventually correct. So it's not a matter of that at the moment. It's just that when you audit, more than half the network has to agree on something. And that's actually an interesting quirk, is if any miner gets to more than half the network, they can actually double spend and reverse transactions because they can self-verify. So the verification is not only that somebody has proposed, here's the solution for this 10-minute chunk, but that more than half the network has accepted that solution and stored it in their ledger.
Yeah, that's why at the beginning I put trusted in the codes, yeah? Because there is a website that lists how much it costs you to attack any blockchain. So in principle, you can attack, doesn't matter, with inclusive Bitcoin, but it costs you. So Bitcoin being the ground level of blockchains is the most expensive to attack, just because of the CPU power. Yeah, because to spin those CPUs, you waste energy. Yeah, so but that energy costs you. Yeah? So I mean, right now I will go later, but the amount of energy that Bitcoin consume goes equivalent to energy expense of a company. Yeah, for a block. Yeah, I mean it's like yeah. Okay. So. Yeah, the Satoshi paper explains here how the winning node on the network is rewarded with Bitcoin. And this picture here shows more intuitively how it is, why it is hard to cheat at Bitcoin. Yeah, I mean, if you want to, because the blocks are chained together. If you want to change this block 74, you have 10 minutes at disposal to rebuild all the blocks to the current one. Yeah. So, I mean, I guess with quantum computing, that Google announced they have quantum supremacy now. Maybe that's possible, but you have to be able to do that every 10 minutes. Yeah, you have to outpace the whole network yourself like a single node with computer power to keep up with your version of truth. Yeah, because the transactions that are written in the block, yeah, they are a form of truth, but once accepted by the network, it's very hard to change. Yeah, and this is an example of Bitcoin mining equipment. I mean, you have like farms of racks of hardware, and moreover, there are mining pools where a group of miners they get together and they work toward one goal to find the winner block, and actually the reward is split between the participants in the pool. Yeah. And the reason I said at the beginning that Bitcoin is decentralized in the codes, because right now it looks like most of the mining pools are concentrated in China, and there are like up to 10 mining pools now. Yeah. But still the network operates because Satoshi explains here in the paper, yeah, it says at the beginning, yeah, that the Bitcoin protocol was designed so that the miner is incentivized to participate in the network and not go against it, because it will be more rewarding to be a fair player than to cheat. Because if you cheat, then you have to keep up every 10 minutes with this false truth. Yeah. While if you are honest, you have a chance to be rewarded, and you play fair. So this Bitcoin energy consumption index, yeah, we have like terawatts hour per year consumption, and yeah. So once a block has been found, it is broadcasted to all the other nodes, saying that it is the correct one, and the other nodes, they can easily verify if that's the right. Yeah, they just hash that block and check if it is less than difficulty. That means the node is valid, and they don't waste. They not wasting time. They will link to the previous block and start the competition to build the next. Yeah, because it's a race against time, and they lose rewards if they waste too much time. So this, if you go on Symphony. .io, hk.io, you can see how a blockchain operates. This is actually a Bitcoin of murder trees with the transactions, and here the blockchain it has also sound effects. And if the Bitcoin is very busy, you hear like a lot of noise, meaning that the transactions, are quite intensive. And the hard forking is where you have more than one valid block at a given moment. Yeah. So then, how come the nodes decide which block to take? Yeah. So Nakamoto explained in the white paper that the longest chain wins. Yeah. And it is easy to verify the validity of the chain. And at each step, when a miner decides which block to link, he has to see what is the length of the chain and decide which way to go. Yeah? And if you go on Wikipedia, for example, on the blockchain definition, here on the right, this picture shows exactly how hard forking is happening. Yeah. So if you go from the bottom, you see that here it attempts to go to another chain, and the network decides to go on the right. Here is another attempt to fork, and so on. And the governance refers to who is involved in. If you want to change the protocol, yeah, you have developer, miners, exchanges, and wallets that have to agree about the change in the protocol. Here is just how the blockchain investment evolved, and here I make like a summary of all the feature of the Bitcoin, and then Bitcoin has a scripting language that people try to use to build applications. It was quite difficult, and Vitalik, the former University of Waterloo, dropped out. He came up with the idea to use a general purpose languages to include programs inside the transaction, so make blockchain programmable. And we go to the second generation of blockchain. We have smart contracts, and here I explain, for example, this is a Bitcoin blockchain, but here on the right we have Ethereum that Vitalik invented. Actually, in transaction you have code. Yeah. And in the end, I go here to, I don't know how much time I have. So I just wanna end here. There is like the Bitcoin maximalist. Someone that believes strongly in the Bitcoin technology. Andreas Antonopoulos, he wrote more books about Bitcoin and blockchains, and he said that I like this metaphor when he said that blockchains are digital pyramids of our time. That means once you write something in the blockchain, it's very hard to change it. Yes, and what you write, it's the proof. Yeah, it's hard to change something that you put it in the blockchain, and here because there is a lot of opposition against Bitcoin and blockchains. Yeah, and he says the way he sees this technology evolving is infrastructure inversion. He says we have cars. When cars came up, it was strong opposition of people interested in raising horses and keep the old things. But the electricity, when it came up, people were against it. The same with the internet, people were against it. Yeah? And he said infrastructure inversion means that you use all the infrastructure to come up with something new that will negate the technology you build it on. Yeah? So he says the same thing with blockchains. We are now using what technology to build them, but once they are there, they will replace all technologies, yeah, for payments and value transfer. Yeah? And he says that blockchain is very disruptive. So, yeah, we didn't have too much time, but thanks. Any questions, or you have no questions?
I don't think we have
Yeah.
You'll have to come back another time. I know blockchain is a topic